real examples. How blockchain is shaping the public sector. Mr. Henrik Hjelte, Chief Executive Officer of ChromaWay, Sweden.
Hello, hello. Do you hear me good? Yeah, great. I'm Henrik. I'm the CEO of ChromaWay. And when I was 12, I started to do programming and got really into that. So I started at the university studying computer science. But after 1 year, I dropped out because I wanted to do something good for the society. So it's pretty hilarious. Computer science not good for society. So instead, I started to study political science and economics and wanted actually to go into the public sector. So I applied for a job at the central bank, but I didn't get that job. So now I'm coming back with a decentralized revenge. But so that was good because I went back into coding and became an entrepreneur and got to know a developer that worked in that company, and he introduced me to his new project. So he introduced me to Bitcoin as well, and the colored coins project. So he had made this protocol where you can not only use Bitcoin as a currency, but you could issue shares and tokens and things like that, and have it securely transported on the Bitcoin network. That was the only blockchain at the time that we were talking about. So this was in 2012 that he made this source code, and I joined this open source project in 2013. Then in 2014, it sort of broke up into different projects. Vitalik Buterin was in that project for some time, and he came out with an Ethereum white paper instead, and we decided that we think that Bitcoin is more secure than what Ethereum will be, so we instead started to work with a bank in Estonia. So this was in 2014 we started to work, I think, and 2015 we had the first release. So they issued a cryptocurrency, a euro-backed cryptocurrency that was decentralized transfers on the Bitcoin network. It's pretty cool at the time. But then there was basically no blockchain industry, so we didn't get that much appreciation for it. We thought that when we win an award, we get a lot of customers on this. But instead, no one really wanted to work with Bitcoin or the enterprises. So it's an autoplay, I think. If you can turn off the autoplay, that would be cool. Or someone is clicking. So we started to work with the land registry in Sweden instead. And at core, we are sort of a technology company, but we've been working with a lot of cases, also now in public sector. We started off with public blockchains, but now sort of also do private blockchains, and also now coming back into public blockchains. So we have a broad spectrum. So here are some cases that we're working with in Sweden with a land registry. I will talk more about that now. Also doing it in India, also land registry with another concept. We tried to file also tender for the central bank in Sweden to look at the e-currency. We're not sure if that's going to happen, but at least we got to the interview phase, which is good. We're also working with real estate in Canada and Australia, and some other projects. So the Swedish Land Registry project, it's basically a joint project between us, a consulting company, the Swedish Land Registry, two banks, SBAB and Landshypotek. We now onboarded, as we go, more parties, a telecom company that has an identity solution, a consulting company, and a real estate agent. And also some other government agencies and are very sort of hang-arounds to the projects, including tax authorities. So we have working on this in several iterations. We now have basically 2 white papers, but the third white paper will come soon. But it's possible to download from our homepage what we've been doing. You see 2 apps here. That's what it's about, to having a faster and better process to buy and sell real estate. It's now quite a lot of steps involved, and we already heard about this. And land registry in Sweden is involved in process step number 28. And it can take 3 months to do a sale of a house until everything is recorded in the land registry and everything is done. And you do this by papers. So what we're doing instead, we're taking this process, all these steps, and coding a smart contract. It's an off-chain smart contract, as Henrik Hjelte explained. So it's basically a workflow. Another question, we have users using mobile phones that can do this now in a few minutes rather than months. And we have the parties involved, and someone needs to run the blockchain. Since this is a private blockchain, there are reputable companies that are controlling the blockchain. It could also be a public blockchain. We'll come to that later. So this is basically a demo, a little bit how it works. You can actually create various players that are cooperating in a contract. So I'm creating a seller now. We're using digital identity solutions that we're integrating with, so not reinventing everything from scratch. And you create a programmatic contract as a seller, and you're creating an instance. On the right, there's a blockchain, so you can see that everything you do is stored as a message in this blockchain. And the contract now stipulates that you can offer property on the market, you put in some information, and it's stored in the contract. A new block is added with that message containing that data. You can now create a broker and invite him. That's basically what you're doing. And you now have a seller and broker. This is a simulating environment, so you invite broker, just put in the public key here. And invite the broker. It's stipulated by the contract. So that's basically how it works. So you have a message chain where everything you do is stored, and you have some contract code. So this is intended to actually be, this is not Ethereum, this is a technology that we have developed. It's an off-chain client-side validation protocol, so every player validates all the things. But it's intended to be quite easy to read, even by, it looks a bit arcane, but if you look, first you have the fields, the data points in this simple contract, and then you have the actions that can be done. So offer something to the market. You put in a property ID, that's an input from the user interface. And the first thing you do is a guard. That makes you're protecting something. You check that you have the signature of the seller. So only the seller can offer the property to the market. And the state of the contract should be in the initial state. So you can only do this at the start. And then it's quite simple. It's a workflow, basically. You save away some information. You save the property ID that you put in the property field, and you set this new state to be invite broker. And when a new state is invite broker, you have another action that can be done by the seller. So it's a workflow that's driven. And all these changes are protected by digital signatures and are validated on the client. So you have a series of messages that are stored somewhere on a blockchain, and they are replayed by all the actors in the contract. And if you replay the messages, you arrive to the same state of the parameters of the contract. So this kind of smart contracts that we're talking about here can actually be stored on different kind of blockchain technologies, because we're only storing commitments, basically a secure ordering of messages. So it could be Bitcoin and Ethereum, but we are using a private blockchain, so it's run by different nodes, some reputable actors. The land registry might be one. It could be banks, it could be auditing companies, it could be land registries from other countries, it could be tax authorities. If you want to have a private blockchain, which is based on voting and not collusion by the majority, you need to make sure that you design it in a good way, so it's not. Yes, so you have different kind of parties that are not able to collude, so it might be less safe to have only banks in a certain country protecting something, because they might collude. You don't know them enough. But if you have people that are ready to lose something, like auditing companies that have a good reputation, different countries. If you pick participants in a good way, I think that private blockchains can give more security, at least, than we have today. We're also doing another case, not about the processes, but about storing of titles. That is a proof of concept that we did for Andhra Pradesh in India. So they have the problem of corruption and actually corrupt registries. So we are basically making a registry for storing titles where everything is audited. And again, not a single party in control over that. You might not know who to. Right now, it's possible probably to bribe someone at the land registry's IT department to update a database. Without technology, that's impossible because you need probably to bribe not only the land registry, but the auditing company or one of the banks, etc. So it makes it less likely to take over that. So that's the security model of private blockchains. So the difference in Andhra Pradesh, we're focusing on storage and security and transparency. In Sweden and some other countries, we are more looking at processes and coordinating between multiple stakeholders. What we've actually been doing, now we're pretty happy with the technology. That's not the main issue, but that there are it's the legal aspects that is slowing things down. So what actually is a blockchain in the court of law is not really tested. It's probably counted as evidence, etc., but it's not really clearly tested. Same with digital signatures. Now there are coming standards for digital signatures, thankfully. So we're basically trying to make something that can work now. And so one workaround that we're doing is actually create a document, which is basically something that is regulated out of the current state in the blockchain, but also pointing back to the blockchain. So that's like a creative legal workaround to make this actually work in the legal system right now. So making this detached contracts. Need to go into the details, but it's generating the current state when it's finished in a standard approved format. So, yeah. I'm just going to talk a little bit. I don't have slides for everything, but some other legal challenges, of course. GDPR, how can we make sure that we can remove information from the blockchain? I think that's quite solvable, both from technical, cryptographic ideas that we have, but also the fact that it's not necessarily applies to public sector solutions if you design them in the right way. And there is also this idea that you can have identities outside of the actual blockchain and sort of have oracles that can forget you, but even though the things that have happened are on the blockchain. Yeah, so verification of signatures. We have certificate service, and we had some issues with identity solutions not being able to work correctly with certificates. The goal is to make something that's legally working. So blockchain in other parts of government, it's a lot about finding the benefits of decentralization, and we'll have more speakers coming into the details and the benefits of blockchain, so don't need to do a lot of talk about it. But it's quite nice when your customer, the Swedish land registry, goes out to the World Bank and shows some slides and saying this is the ultimate public sector application. So then you're pretty happy as an entrepreneur. There's a lot of benefits to having a decentralized system. So that if you want to have a blockchain, of course there should not be a single party controlling everything. And this is a pretty different architecture compared to what you have now. Right now, you basically have, it makes more sense, of course, when you do transfers between organizations, but those are the most use cases. So what we have now is basically APIs between enterprise relational databases. So you have data silos. And we want to move, probably, you hear a lot of people here saying that we want to move this to the blockchain. It's quite... But right now, we have these enterprise relational databases. And a blockchain, what's that? It's a linked list of transactions. It's pretty hard to work with. So relational databases, they have the market share. The other includes also the NoSQL databases. Blockchain isn't even part here. So how do you actually make a transition to this? So most blockchains are actually key value stores, if at all, and pretty primitive. And we found out that by working with the blockchains, from Bitcoin, we need to index information and see how can we retrieve how much money someone has, etc. We can't just loop through transactions. So then we came up with this idea that we can actually integrate a blockchain in a relational database. So we have a practical Byzantine fault tolerance. This is just some benefits of having a relational databases. Access to developers and platform maturity. So don't have much slides about this kind of technology, but it's quite simple. You have a Byzantine fault-tolerant voting scheme, just like any other blockchain. You're storing actually a low-level blockchain in the relational database. But coding is done directly in SQL, if you wish. So it means that any developer can actually implement a solution. So a registry, that can actually be a table, or several tables that you join together. And validation, that's basically what the relational databases do. They validate things in a perfect way, using all the features that have been built up since the 70s on this. So we think that's quite a game changer if you want to implement solutions for the public sector, as well as a lot of enterprise solutions. So this is our product for private blockchains. But we're now also releasing a new product, basically a public blockchain again. Also working with this idea to have a relational database combined with blockchain. So we heard about decentralized applications, but it's quite hard to do right now. If you want to make a decentralized Facebook using a NoSQL key value store, it's pretty hard. Facebook has built quite easily with MySQL in the start. Just hack together a relational database solution. Now they have 1,800 servers. But we want to bring this model into blockchain programming. So we think it's quite a lot easier to do implementations, as well as more performant. So we are now coming back to the public blockchain using basically an alternative to Ethereum to make really complex solutions. Yeah, that's a little bit about what we're doing in public sector from my company. Thank you.